Let's talk for a minute about the difference between the terms mass and weight. These are used incorrectly all the time, even by teachers, even by scientists. I might tell you to go weigh something, when really I'm asking you to go get the mass of it. So let's talk about what these terms mean. Mass is how much matter is inside of an object, and your mass never changes unless the object changes size, like a child growing, if you cut something in half, something like that. So that's the only way mass ever changes. The SI units for mass are kilogram, and sometimes you'll also see it in grams. Weight is a force. It is the force on an object due to gravity. And this changes depending on the acceleration due to gravity, which we represent with a g. And that changes at large distances from the center of the Earth, very high up in the sky, and on other planets. The gravitational force is determined by the mass of the two objects and the distance between them. So heavier planets have more gravity, and lighter planets have less. And as you get further and further away from the planet, you get less and less gravity. You just have to get very far before you start seeing this difference. To calculate weight, it's a force, so we're going to use force equals mass times acceleration. But since we're using weight, we're going to do mass times acceleration due to gravity, because weight is the force due to gravity. So it's the exact same equations, F equals m times a. We're just using a very specific acceleration because we want a very specific force. Let's look at some example problems. We're talking about different locations like Earth, 1,000 kilometers above the Earth's surface, and a couple of different planets. And I've given you g, the acceleration at those locations due to gravity, and I want you to find the weight. And because weight is a force, it's still going to be measured in newtons. So let's take, for example, a person with a mass of 68 kilograms. That's equivalent to about 150 pounds. So to find their weight on Earth, we would do mass times acceleration, 68 times 9.8, and we'd get their weight is about 666 newtons. And you can do this with your own weight if you would like. If you take your weight in pounds and divide by 2.21, you should get your weight close to kilograms. So if you want to test this with your own weight, please feel free. It's interesting to see what you would weigh on different planets, I think. So if we're 1,000 kilometers above the Earth's surface, our weight would drop to 498. It's a pretty big change. 1,000 kilometers, pretty much the only thing up there is satellites, just so you have an idea of how high. On Mercury, which is a smaller planet, so it has less mass, our weight would be about 245. On Jupiter, which is a very, very dense planet, I believe it has the most mass of all of them, our weight would be 1,768 newtons. So it would almost triple from what it is here on Earth. If you imagine trying to walk with that. On Pluto, which isn't a planet anymore, but is very light, you would only be about 41 newtons. You would just float away. And on Venus, which is probably the closest to Earth, you'd be 600. So the next time somebody complains about their weight, you should tell them they don't need to go on a diet, they need to go to Pluto or to Mercury. So hopefully you understand the difference between mass and weight, because on all of these locations the person's mass is still 68 kilograms. The only thing different is their weight, the force that is pulling them down.